This is 6.3, and it is called Function, Operations, and Compositions. Function, Operations, and Compositions. Okay, so let's see what we know about this, just by reading the title. So we're dealing with functions, right? What are the operations that you know that you can do in math? Add, subtract, multiply, and divide. So those are the things that we're going to be doing. Can you add, subtract, multiply, and divide functions already? Huh?
Modular? No, that's just
Modular?
No, that's just
yeah, listen, can y'all add, subtract, multiply, and divide functions anyway? Yeah, you know how to do that, okay, so that shouldn't be an issue. And we're going to go over it, show you some of them, okay? The compositions, you've not ever done before, okay? So we will look at compositions. Now, here's the important part, compositions. If you don't know how to do compositions, will you miss some problems on the test from this section?
Yes.
And the next section, too. Because that's the way it works, okay? The next section, you have to know how to do compositions. So, that's 2 out of the 4 sections, so you need to make sure that you understand it, all right? And I'll give you a worksheet, and it will be due on Thursday, and you'll take the test Thursday and Friday, okay? All right, so let's do this. Let me tell you the 2 different ways they can write it. They can say, what's f of x plus g of x? Or they could write it like this, f plus g of x. Most of the ones that they're going to talk about in Algebra 2 are going to be written like the left-hand side. But I'm telling you this over here because in pre-cal, in upper level classes, a lot of times, pardon me, they'll write it like this. And you know that that means that you could possibly see it on the SAT like this, right? And it'll be crazy, like you know how to do it, and then you just didn't know what they were asking for. Abby? Mm-hmm. All right. There's also subtraction. It looks like f of x minus g of x. That's most of the way you will see it. But you could write it, and it would be the same thing, f minus g of x. Multiplying f of x times g of x, or f times g of x. Division, most of the time after you get into algebra, we write division not with the division sign, but as a fraction. So f of x over g of x, or f over g of x. Okay, so this, y'all, I just want to make you aware that maybe on the SAT or ACT they may write it like this, but don't wig out. You already know how to do it. It's not a big deal. Okay? So let's try our first problem. Example 1. Example 1, I'm going to tell you that f of x is equal to 4x to the 1/2 minus 2, and g of x is equal to negative 9x to the 1/2 plus 5. Okay? They're going to ask me to do 2 things. The first thing they want you to do is find f of x plus g of x. Alright, now this is not hard, guys. All that means we're going to do is what? Yeah, you're just going to add these 2 functions together. So f of x is 4x to the 1/2 minus 2 plus g of x is negative. Oh, when you have plus a negative, what is it? It's minus, guys. Okay? Don't put plus a negative. X to the 1/2 plus 5. Alright, we collect our like terms. What are these like terms right here? Okay, so what is 4x to the 1/2 minus 9x to the 1/2? Very good. So I have negative 5x to the 1/2. What's a negative 2 and a positive 5? And that's my answer. Okay? Now, here's what I say. On this one right here that you subtract, I suggest that you always put that second one in parentheses. Because if you don't, a lot of times you're going to change the sign of the first term, but if there are any other terms, you'll forget and not change that sign, and that'll make you miss it. Okay? So let's go back to this right here. This time we're going to find f of x minus g of x, and I want to make sure and put the second one in parentheses. Okay? So f of x is 4x to the 1/2 minus 2 minus, open parentheses, negative 9x to the 1/2 plus 5. Now, what is that minus sign in front of those parentheses going to do? Yeah, he's going to change the sign of everything, not just the first term. Y'all, that's the most common made mistake. Okay, if you were taking an SAT test, would that be one of the answers where they just changed the sign of the first? Yes, because guys, listen, when they have a multiple choice test, that includes in this class, do you have some multiple choice questions on your test? Always, okay? They're going to have the correct answer, and then they're going to have the most common made mistake. That's for you when you make that common made mistake, and then you go, oh, I got it right because my answer's on here. Okay, and then they're going to put the second most common made mistake, and then they're going to put some crazy answer. Okay? So, are you going to leave a multiple choice blank? Why would you do that? Alright? So, 4x to the 1/2 minus 2. What's the opposite of a negative x to the 1/2? So, positive plus 9x to the 1/2. What's the opposite of a plus 5? Alright. What is 4x to the 1/2 plus 9x to the 1/2? Perfect. And what's a negative 2 and a negative 5? Amazing. Now that's not hard, is it? That's not hard at all. That's pretty easy stuff. Okay, we're going to do the multiplication and division now. And with those, we're going to kind of review something that maybe you haven't thought about in a while. All right, so this is example 2. I'm going to tell you that f of x is equal to 6x and g of x is equal to 5x to the, now let's say 2. The kids wanted to make it that, but I'm not going to. 2x to the 3/4. Okay, so let's do this one. F of x times g of x. Well, guys, that simply is 6x times 2x to the 3/4. A piece at a time, right? What's 6 times 2? 12. If this doesn't have an exponent, can I write a 1 right there? Okay. When you multiply, what do you do with your exponent? Add. So what's x to the first times x to the 3/4? X to the 7/4. 1 is 4/4. 4/4 and 3/4 make 7/4. That's not too bad, is it? All right, let's do this one over here. We're going to say, what's f of x over g of x? Okay, what is f of x? So 6x on the top, and g of x is 2x to the 3/4. Okay, now when you have a fraction, what do you need to be looking to do?
Make it more.
Reduce it, right? Reduce things. Okay, so let's see if we can reduce. What's the first thing you see? 6 and 2. What is it reduced by? 2. 2 goes into here 1, and 2 goes into here 3.
You can reduce the x.
Okay, so Spencer looks at this and he goes, man, there's an x on top and an x on bottom. I probably need to reduce those things, right? Do you always need to reduce them? Okay? What if it had this? Okay? Pretend. It's a whole different problem. It's in pink. We're pretending. What if I had x to the 3/4 on the bottom and an x to the 1st on the top? Reduce that?
No.
I know. I said it backwards. I said we're pretending.
No, you actually say it backwards.
Did I say it backwards? Oh, sorry. What if I had an x to the 3/4 on the top and an x to the 1st on the bottom?
No, because
It looks like you want to reduce it, right? Because you got x's on the top and bottom. Do you want to reduce it?
no.
Why?
Because the M's have to get the fractional exponent out of it.
Very good. Okay? So here's what Spencer said. Spencer said, well, you're still going to subtract them, guys. So that's going to be x to the 3/4 minus 1 is 4/4. So that's going to be x to the negative 1/4. Good answer?
No.
No. Why? Can't have a negative exponent. So what do I do with it to make it positive?
Or you put it under.
Put it on the bottom. So now it looks like this. Good night. Shut the door. Okay. Hang on just a second. Sorry about my mouth. Okay. Okay, so I explained how to do all this problem, people, on the recorder, but I'm not going to do it again because I don't have time. All right. So anyway, you have to be careful. So I look at this one and I say, well, I got to subtract them. 1 minus 3/4. Is that a negative number?
No.
Okay. And if it were a negative number, I would see if it was going to be a fraction. If it's a negative fraction, that's a problem. Okay? What is 1 minus 3/4? 1/4. So this is 3x to the 1 minus 3/4. So that's 3x to the 1/4. Good answer? Yes. Perfect answer. Nothing wrong with it. Remember the things that you cannot have. No negative exponents, no fractional exponents in the denominator. Okay? All right. Anybody got a question? Okay, so I'm going to erase all this mess because I want to ask you another question about these problems right here. What if I asked you to tell me the domain of these problems? Oh, yeah. No, I don't want you to use a calculator. Okay? Now, here's the deal. Could I use a calculator to justify that, yeah, I'm on the right trail? Yeah, that's a good thing to do, guys, okay? But let's just say we wanted to talk about this thing right here's domain. If I'm going to talk about, when I say the word domain, what should come into your mind? No. 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 Nope. The other class didn't remember either. No. When I say domain, you used to say x's, right? But now when I say domain, you need to think restrictions. Do you remember this? Restrictions. Okay? How many restrictions did I make you learn? How many restrictions did I make you learn? 2. Very good. Okay? Does anybody remember what those restrictions were?
It has to be greater than something.
Only? I can't say that because it's only true sometimes. Here are the 2 restrictions. 1, if you have an x in the denominator. Why does that create a restriction?
It'll never cross the...
Why does an x in the denominator create a restriction? What can't be in the denominator, people?
0.
0. So if you have a number that creates a 0 in that denominator, then that number has to be excluded from your domain. Because you can't have 0 in the denominator. My function is undefined there. Okay? Now, so an x in the denominator. Yeah, what are you going to do? This is what your rules say. You set the denominator equal to 0 to solve for x, and you exclude that number from your domain. Anybody know what the second restriction is? Right? It's not a big deal, guys. You just have to remember this. No. An x under the, there you go. An x under the radical. Dadgum. Hey, Spencer, shrink it down and see if it's still connected. Thank you. It's okay. Give it a minute. All right, perfect. Okay, so your second restriction is an X under the radical. Okay? Now look, if you need to, these are the things that you need to be writing. An X in the denominator, what are you going to do? Set the denominator equal to 0, solve, exclude that from the domain. Now listen, people, you need to know this, okay? We've already excluded that. That's what that said. Set the denominator equal to 0, solve, and exclude. That's an EX. It looks like a bunch of lines. Okay? An X under the radical. What kind of numbers can't be under the radical? Negative numbers. Because when you take if you're talking about even roots, odd roots can have any, but even roots can't have negatives because then you would be imaginary numbers, right? So only if it's an even root, okay, and you would set what's under the radical, what? What does he have to be? Or greater than or equal to 0, and then you're going to solve it, and that will be your domain. Okay, so what am I talking about?
What is that in?
Exclude that. Whatever you get when you solve it. Whatever number you get when you solve it, that's what you have to exclude. So, let me give you an example, okay? Let's just work two problems really quick. Here's the first one. Here you go, right here. Okay? Let's talk about his domain. When I say domain, what do you think? Restrictions. Does he have any restrictions? People, it's not like I asked you to memorize 50 of them. How many do they have? 2. 2 restrictions. Okay? X in the denominator, X under the radical. So, I have an X in the denominator. So what do? You take that denominator, you set it equal to 0, and solve for X. When X is 6, what do I get in the denominator? 0. So what do I have to do with that? So what is my domain? Interval notation. Negative infinity to, come on guys, 6 excluded, then union, perfect. Come on guys, y'all are not remembering stuff. You have to remember stuff. Guess what? Everything that I've taught you this year, you're going to have to know it next year. Okay? So, here's the next one. Oh, let's just do this one. 12x to the 3/4 power. Let's talk about his domain. Does he have any restrictions?
Yeah.
Why?
Because it's an odd number in the radical. No. Is it not an even root?
It is an even root. What's the root? Y'all, that's a 4th root right there. That is a 4th root right there. Okay? So, here's what you're going to do. Look, this is what it looks like. 12 times the 4th root of x to the 3rd. Whoa. So what did your rules say to do? Take what's under the radical and say you have to be greater than or equal to 0. Okay? What's under the radical, Billy Gates? 6x to the 3rd. All right. Now, because this is kind of a special one, all right, one way I could do it is I could graph this thing, right, and see where's this graph what? Where's this graph?
Greater than or equal to 0.
And what would I be looking for? Where is it above the x-axis? Where it's above the x-axis. Okay? You know what the cubic function looks like. It looks like this. Okay? So from 0 all the way to the right, those are the x's that will give you above. Okay? So what does x have to be? Greater than or equal to 0. How do I write that in interval notation?
And the X.
0, nope, interval notation. 0, how do you do included?
0.
A bracket, very good. From 0 included all the way to perfect. Very good. Okay, so now let's talk about a composition. Okay, let's talk about a composition. Now this is something you have never done before, all right? Composition of functions. So it looks like this. F, and that's why the kids, if you ask older kids and they said, what are you doing? And you said, we're doing fog and golf. They would go, oh yeah, I know how to, that's not bad, okay? But that's what they call it. It's not really an O, is it? How do I know it's not a time sign? Yeah, it's not solid, it's just a hollow dot, okay? So it's F composition G, and we're also going to find G composition F. Of course, I could use any letters. All right, now, here's what they mean. I like it written like this, and I would venture to say most of the time you guys are going to see it like this. I don't even see it in y'all's book written this way, but y'all listen to me. If you see it on a SAT or an ACT test, they're going to write it like this. Okay? I always rewrite it like this. F composition G means F of G of X. Guess what G composition F means?
The other way around.
G of F of X. Composition is just it's just what you do. Now y'all listen. I'm gonna tell you this is not hard, okay? So don't go, oh my gosh, I'm never gonna get this. It's really easy. So they're gonna tell you two functions. Obviously, I'm gonna use F and G. So I'm gonna tell you that F of X is X squared minus 2X plus 1. And then I'm gonna tell you that G of X is equal to 2X plus 3. Okay? Now, here's what we're going to do. The first thing we're going to do is we're going to find F Composite G. Now, what is F Composite G? What does it really mean? F of G of X. Now, this is why I like to write it this way. Because when you write it this way, then y'all, you can follow the simple rules that you've been taught in algebra since junior high. Okay? So if you have more than one set of parentheses, where do you start working?
At the very intersection.
At the very inside, right? Well, look, Spencer, we can't do anything with that X, can we? We don't know what he is, so we're just stuck. Okay, but let's move out a little bit. Do I know what G of X is?
Yes.
Then let's plug it in there. F of, what is G of X? So I'll put it in his place. Now, does everybody understand what I did? All I did was I took what G of X is equal to and I plugged it in for it. I substituted. That's what y'all called that in geometry. Okay?
But wouldn't we have to put the X on the inside still?
Now,
Oh, that's the entire X.
okay, that is G of X. All right, now, here's where the guys are going to have an issue, okay? Because we're going to have to follow directions, okay? And we all know that they don't like to ask for directions, right? Girls, if you're riding around with a guy and they get lost, they're just going to ride around until they happen to end up somewhere where they realize it, okay? They're not going to stop and ask someone, which way do I go to get to whatever. All right, so here's the directions. Do you see this letter right here? He's telling you where to go. He says, hey, go to the F function. Here's the F function. What did I put in place of this X down here? What is it? 2X minus 3. What you do to one side, what, plus 3, pardon me, 2X plus 3. What you do to one side, what? You have to do to the other. So guys, listen to me. If I put 2X plus 3 in place of this X, what do I have to do over here?
Oh,
Put 2X plus 3 in place of every X.
that's why
So,
we do F of X.
There you go. So there's an x. What am I supposed to put?
2x plus 3.
Perfect. And I square it. Minus 2 times, there's another x. What do I
2x
put?
plus 3.
2x plus 3. And then plus 1. Don't forget your little plus 1. Okay? Now, y'all, look what you did. You plugged this function inside this function. That's all you did. Okay? You plugged g of x inside of f of x. Everywhere there was an x over here, you plugged this dude in. Okay? Now, that's not the hard part, Spencer. Here comes the bad part. A third of the class doesn't know how to square this, even though your teacher has pounded it in your head for the last 6 months.
So, can I,
Yes, what?
the f of 2x plus 3, is that basically equivalent to 0 at this point?
No.
No, okay.
No.
So
Don't
it's
be
not
making
like
stuff up. I don't know where you even got that.
What do you make up?
Okay? All right. Now let's just square this. Please, let me just warn you right now. If you think it's 4x squared plus 9, you're wrong. Okay? So, tell me what it is.
4x squared
Square the first, right? What's next?
plus 6x.
Keep the sign. Plus 12x. Very good. It's twice their product. Their product is 6x, and twice that is 12x. Plus, square the last. 9. Distribute this negative 2 throughout there and tell me what you get. Minus 4x minus 6. And then plus 1. Let's collect all of our like terms. 4x squared. This is the only x squared. What's 12x minus 4x? What? 8x. So that's plus 8x. Okay? What's 9 plus 1? 10 minus 6. So plus 4. That's my answer. Y'all, that is F Composition G.
Oh, do you not need to pull the 4 out?
No, don't factor it. Just find it and then say, yahoo! Write it down and go on to the next problem. Okay. All right, now let's do the other one. Let's do G composite F. G composite F. What is that the same thing as, guys? G of F of X. Okay? Now what are you going to do? Very good.
Yeah.
G of, and it's going to be, I'm going to plug F of X in. So G of X squared minus 2X plus 1.
This one's easier.
Yes, it is. So, do you have your directions, guys? Which function are you going to? The G function. In place of this x, I'm going to substitute x squared minus 2x plus 1. So, 2. There's an x. What am I putting in there?
X squared minus 2x plus 1.
And then plus 3. Okay?
There's no way to factor it.
We're not worried about factoring it.
I know, but I was just
Okay?
thinking.
All right. So now we're going to distribute that 2 throughout those parentheses. Two times x squared is 2x squared. 2 times negative 2x is negative 4x. And 2 times 1 is 2. Any like terms? And so my answer becomes... Is that right? What about his domain? What would his domain be? When I say domain, what do you think? Does he have any restrictions? Then what's his domain? Very good. Negative infinity to positive infinity. Okay? Now look, let me tell you this. Okay? We're not going to talk about it this year, but next year you will talk about it. When I talk about this composite functions domain, I have to talk about this guy right here's domain. Any restrictions in this guy's domain, and they better be included in this guy's domain. Okay? But we're not going to talk about it this year. All right, anybody got a question? Okay, so then the kids said what? What's the famous question everybody always says? Yeah, when are we ever going to use this? This is stupid. When are we ever going to use it? Okay, so here we go. Girls, we're sending the guys to the paint store because we need to paint the dining room. Okay?
Hey, that's what we're doing.
So, here's what you have. You have a $10 gift certificate.
Yeah, paint stores are expensive.
Okay? And the store is offering 15% off your entire purchase. That's right. All right? 15% off the entire purchase. Okay? This is what you are going to buy. You're going to buy a $30 can of paint.
I have a question.
What?
Which is more beneficial, to take the 15% off first or second?
That's my question, Luke. Okay? Don't be stealing my thunder. A $30 can of paint, and we're going to buy $25 worth of supplies. Because you know you have to buy all that tape, and then you got to buy new paintbrushes, a tray, a roller, and all that mess.
Well, shouldn't the register already be geared to make the table nice? Yeah, that's what I was thinking.
Okay,
Yeah.
but here's the deal. Now, y'all, I'm telling you this, too, okay? That if you're a smart person, you know which one to do first. You know the order to do it in. So, here's the deal, is that some of you guys don't know. So, let's see what's going to happen. What if I use my gift certificate first? Okay? Now look, hang on just a second. We're going to compare that to using your gift certificate last. Now, can I make this happen? Can I control this situation? People, when I check out, if I give them my gift certificate, what are they going to do? They're going to take it off. Okay? If I don't tell them I have a gift certificate and then they take 15% off of my thing, then I say, here is my gift certificate. Then they'll take it off. I'm controlling the situation. I know which one I want. All right, let's see if it makes a difference. Okay, so first of all, how much do we spend? $55, okay? And then over here, what are we going to do first? Take that $10. So now how much are we spending?
45.
So now my bill's 45, okay? So now I'm going to subtract 15% of that 45. So I'm going to say 0.15 times 45. Now, some of the really smart kids in this class, instead of multiplying 15 times 45 and subtracted it, they just multiplied 45 by what?
No, what?
85. And that means you paid 85%. That's okay. I'm okay with that. Some kids don't ever get that, but we can do it this way. So this is 45 minus, what is 15% of 45? Okay, 6.75. So 45 minus 6.75 is $39.25. Everybody okay with that?
Wait, what? No.
Oh, it's 38? Is it 38?
No, yeah, it's 38.
It's 38. Yeah, it's 4. Okay, sorry. I borrowed. I forgot I borrowed. All right, over here, let's see if we do our gift certificate last. All right? This is my column, guys. I'm telling you now. Okay? I'm going to say, here's my stuff I'm buying. And he's going to say, oh, okay, Miss Davis, we have a sale today, and you get 15% off of your entire purchase. So,
Like Kohl's is like, oh, here, take an additional 15%.
okay? So now we have 55 minus, what's 15% of $55? $8.25?
Okay, I got this.
Okay. So, oh my word, people, you only saved $6.75 with your 15% discount. I saved $8.25. I saved $1.50 more. Okay? So now my bill is what? $46.75. And then what am I going to pull out of my purse? Oh, by the way, I have a $10 gift certificate. So now my bill is $36.75. Okay? And then the young people say, oh my word, it's just $1.50, right?
No.
Like,
Surprised that they count that.
it's my $1.50, and besides, if I was working for someone, which is what you will probably all grow up to do, right? And they sent me to the store to buy paint for the whole building, then my bill might not be, I might not be buying $30 worth of paint, but $3,000 worth of paint. And is it going to affect the purchase, you know, how much I'll save? Yes, guys, that's important stuff. Okay? All right. So let me tell you what we're going to do. And I'm going to say it while we're recording because I want it to be recorded in case someone's parent wigs out on me. Okay? And I'm going to play it back for them. So I'm fixing to pass you back your test that 90% of you did horrible on. Okay? I'm going to let you, shh, don't talk. I'm going to let you erase the bad things on your test and rework the problems for half credit. Does everybody understand? Now, because some kids did well, and I certainly don't want anybody catching up with them, that's not fair, right? If you have an A or a B, I will add points onto yours before you even start. Okay? So you're already out of reach of anybody else. Okay. So everybody understand the game. You get your paper back. If you missed a problem, erase that. I'm going to go back and regrade it. Anything that has a pink slash on it, it's just -4 points. If it was partial credit, it'll say minus however many. Okay? And you erase whatever you need to erase to make it right. Okay, let me tell you this. After you've corrected it, I want you to write in pencil. I want you to write in pencil why you messed that test up. I made careless mistakes. Yeah, no. No. I should have looked at the what?
Instructions.
No. Yeah, the YouTube videos. Okay? I should have, whatever it is, I want it written in pencil. On your paper, after it's written in pencil, I want your parents to sign in pen. That will be worth enough points, guys, that you just want to suck it up and do it. Does everybody understand me? Now, let me make you understand this. Will I know if you wrote pencil over your parents' ink? Yes, I will. I can tell, guys. All right? I can tell. So, let me pass your papers out to you, because I certainly want you to leave here with a smile.